So today we're going to start Unit 2. Okay. So new note packet, new homework packet, and then the old ones, the Unit 1 homework packet and note packet. That's 100% on you, whether or not you decide to keep it, chuck it, whatever you want to do with it, that's up to you. Okay? All right? If you didn't turn in the boot camp on Friday, that salmon sheet that we worked on in class on Friday, if you needed some time to finish that, make sure that at some point in time before you leave today that you turn that in to the basket. Okay? With that being said, then we will start on page 2 of your note packet. 3/4 of a page, looks like almost 2/3 of a page of stuff. So Unit 1 was all about sequences and series, or actually just sequences, not series. All about sequences. So the first 3 are, is it arithmetic, is it geometric, or is it neither? And then give me the explicit and the recursive. The next 2 are finding the unit rate, that's the rate of change. Okay? Right? And then 2 solving equations. Okay? So I will give you, what do you say, 5 minutes? 5 minutes sounds like a great plan. I'll give you 5 minutes to get those done. Go. First one, part A. We'll go. That's what I mean by the first one. It's all in number 1. Part A, arithmetic, geometric, or neither? Geometric, because we are multiplying everything by 2. So we're always multiplying by 2. So that means my recursive would be f of n equals 2 times f of n minus 1. First term is 4. Agree with me on that one. Okay? Which would make my explicit then 4 times 2 to the n minus 1 power. Do we agree with that? Yeah? Okay? All right, love it. Second one, B. What are you shaking your head at, Kurt? Neither, because it goes up by 3, and then it goes up by 5, right? So it's not arithmetic. Okay? And the first one you multiply by 2.5 to get 5, but then the second one you only multiply by 2. So that didn't match up. The R values didn't match up, so that one definitely is a neither, which means we can't do a recursive, we can't do an explicit. Okay? All right? Third one, C. What are we thinking? Arithmetic, geometric, neither. Arithmetic, why? We're adding 3 every time. Okay? So that means my recursive then would be f of n equals f of n minus 1 plus 3, with my first term being 6. Yes? Okay? And then this would be f of n here equals 3 times the quantity n minus 1 plus 6, or 3n plus 3. With me on that one. Okay? All right? Love it. Unit rate. Okay? A dozen ears of corn for $5. That means that my unit rate would be $5 per dozen. Okay? 3 t-shirts for $10 would be 3 t-shirts. Oops, there we go, t-shirts per 10. Actually, here we can just do it. We don't have to write out dollars. Oh, have to write it in there now. Okay. For $10. Okay. Unit rate is just the rate of change. It's just written with its units. Okay? So instead of saying plus 5 here for dozens of corn, okay, it's $5 per dozen. Solving each equation, 7 times x equals 42. So 7 times x, so I'm going to divide by 7. That cancels out my 7's there. Leaves me with x here equaling 6. One-fifth times x. If I multiply both sides by 5, now in my brain I've got 5 over 1 times 1 over 5, which is 5 over 5, which is just 1. So this 5 cancels out that 1/5, leaving me with just x equals 20. Okay. Good to go on that one? Love it. Any questions on those first 5? All right. Let's go on to page number 3. Okay. My little sister Savannah is 3 years old. She has a piggy bank that she wants to fill. I still have my piggy bank. It was a choo-choo train. It was made out of wood. Okay. It's actually still sitting on my dresser in my bedroom now. I'm 50 years old. Okay. She has a piggy bank that she wants to fill. She started with 5 pennies. And each day when I come home from school, she's excited when I give her 3 pennies that are left over from my lunch money. Use a table, a graph, and an equation to create a mathematical model for the number of pennies in the piggy bank on day n. Okay? So, how many piggy banks does she have? But she only has 1 piggy bank. How many pennies does she have in the piggy bank when she starts? 5. She's got 5 in there, right? Okay. What day is that? It's what? It's day 0. Now, it's day 0 because it's the start. So at day 0, she's got 5 pennies in the piggy bank. Okay? Then I come home from school, and what happens? I give her 3 pennies, right? Okay? So now how many pennies does she have in her piggy bank? 8. Okay, and it's day 1. Next day. Day 2. How many pennies? 11. Day 3. 14. Day 4. 17. Day 5. 20. Day 6. 23. Day N. Don't know yet, right? Okay. All right. What kind of a sequence is this? Arithmetic? Why is it arithmetic? Adding 3 every time? Yep. Okay. All right. So let's put this on a graph just to prove that it is. Because if we graph this, what is the graph going to be like? It should be a straight line, right? Even though that's the Department of Redundancy department. Did you know all lines are straight? But people always say straight lines. Okay? All right? So let's go. We want to go days on the bottom or days on the side? Days on the bottom. Okay? Which means we're going to do what on the side? Pennies. Number of pennies. Okay. You want to go by 1s, 2s, or 3s? Go by 2s? Okay, go by 2s. Okay, so then this would be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 24, 28, 32. So day 0 had 5 pennies. 2 had 11 pennies. Day 3 had 14 pennies. Day 4 had 17 pennies. Day 5 had 20 pennies. Day 6 had 23 pennies. And that's where we stopped. Do we still agree that it is arithmetic? Because the points are all in a row, in a line? Yes? Okay. Hold on, do you agree with that? You have no idea what you're agreeing to, do you? Do you know why? You can't focus. So tired. You know what I mean? I'd rather have you gone for 30 seconds and awake than snoring here in 30 seconds. You know what I mean? Okay. Okay. So what would my recursive equation be for this one then? F of n. That's it?
And then f of 1 equals 8.
And f of 1 equals 8. Or any of those, right? We could have gone f of 0 is 5, f of 2 is 11. Any of those we could have put in. Right? Okay. What would my explicit equation be? What? F of n, I like it.
Equals 3 n minus 1
Times the quantity n minus 1. That's how we say that. Yep. Okay.
plus
Plus 8. Yep. I would agree with that. Okay. Or, what else could it be?
F of n equals 3n plus 5.
Yep. We would put it in y equals mx plus b1, right? Okay. All right. Now the next question says, how many pennies will she have after 1 year? Well, we're in days, right? Right? We're in days. How many days are in a year? 365, right? We'll go with non-leap year type of year, a regular normal year. 3 out of the 4 are regular ones. Okay, so we'll go with that one. So we would want to know how many pennies she's got after 1 year. So let's go 365 into my function. Oops, put it in the wrong spot. So we would go 3 times 365, then plus 5. 3 times 365. Woo! Now I see why you guys came up and grabbed calculators. Stand here, clear. 3 times 365 gets me 1,095. So she would have 1,100 pennies after 1 year. Yes? Okay. So she'd have $11 in the bank. Okay. My question to you is this. Can I draw a line that connects those dots on the graph? Based off of, I know I physically I can, right? But based off of this scenario that we have, that Savannah, right? It was Savannah and her pennies. Can I connect those dots? Think about the scenario. Think about the scenario. Can I connect those dots? Meaning, what I mean by that is, if I were to, we'll go here. If I were to go right here, is this, so that right there would be 2.5 days. Yes? Does she have 13 pennies on 12 and a half days? Why not?
Her brother hasn't paid for the money yet.
Her brother hadn't given her the money yet. Her brother or sister, I didn't even say. Was it?
I just assumed.
Okay, just assume brother. Okay, because brothers are nicer than sisters. Yeah, I said it, Lucky. I have a sister. Okay, all right. So sibling, we'll say sibling. Siblings at school, right? So can that point be part of our graph? No. So we can't be in between those points. We're always just jumping those 3 pennies every single time. Okay? This is what is called, we do not connect them. Oops, I don't know. I was going to start with them. Do not them connect. This is what is called a discrete function. Meaning your input, in this case, what was the input again? What's the input? Days. The number of days, right? The number of day it is. The input is the day. That's we only are inputting whole days into it. Okay? We're not. Sibling is not coming home halfway through and allowing us to do that. Okay? Understand that? All right. Let's go down to the next one. Now, our family has a small pool for relaxing in the summer that holds 1,500 gallons of water. Okay? I decided to fill the pool for the summer. I was getting bored just standing there watching water flow, and I began to think about a mathematical model, because, when you're filling a pool, that's all you think. You just think straight math. Okay? Okay? For the time that it takes the pool to fill while I was waiting, I checked the flow of the hose and found that the pool was filling at a rate of 2 gallons every minute. Okay? When I had 5 gallons of water in the pool, I started the timer. Okay? So at 0 time here, at 0 minutes, how many gallons are in the pool? 5 gallons are in the pool. Okay? Use a table graphing equation to graph T pool minutes. Okay? After 1 minute, how many gallons are in the pool? 7, right? Because it's filling at 2 gallons per minute. It's adding 2 gallons every minute, so then there would be 7 there. After 2 minutes, 9. After 3 minutes, 11. 4 minutes, 13. 5 minutes, 15. 6 minutes, 17. And then we'll leave our space there for T. We want to figure out how at T. Okay? What kind of an equation is it? Arithmetic? Okay, because we're adding. Okay, all right. So let's graph this one. On the bottom, what's our input label? No. Minutes. Input label is minutes. That's what's changing. 2, 4, 6, 8, 10, 14. Okay. And then what's my output? Gallons. What do you want to go by? Ones? Twos?
Choose.
Twos probably? Okay, that's fine. I'm fine with that. 4, 8, 12, 16, 20. So at 0, we're at 5. 1, we're at 7. We stopped at 6. Okay, but but we're still filling, right? Okay, so we could keep going on and on and on and on, just like in the last one. We could have kept going on and on and on and fill that one up. Okay. Recursive equation here. F of n equals f of n minus 1
Plus 2.
with f of 1 being 7, or f of 0 being 5, or f of 2 being 9, or any of those. Yes? Okay. Explicit equation. F of n equals 2 times the quantity n minus 1 plus 7, or 2n plus 5. Right? Okay? My question to you, before we figure out how many minutes it's going to take for the pool to fill, my question to you is, can, in this scenario, because you got to go by each scenario, in this scenario, right here would be, what is that, 3.5 minutes? At 3.5 minutes, is there 12 gallons of water in the pool? Yes. It's not just, the hose is not waiting for each minute to spew out 2 gallons. And then a minute later, it spews out 2 more gallons. And then a minute later, it spews out 2 more gallons. It's constantly flowing there, right? So can I connect these dots? Yes, these dots I can connect. If I want to. Okay? Those dots I can connect. Now I should go back and I should put in my so that you see that. Yeah? How many minutes will it take for the pool to be full? Am I going to plug in? Well, what am I plugging into my equation? My explicit equation right here. What am I going to? What's the one change I'm going to make? I'm going to what? The output. What's my output need to be? 1,500, right? So is that? Am I going to put 1,500 in for n? No, I'm going to put it in for f of n, right? I want my output to be 1,500. So 1,500 is going to equal 2n plus 5. Need to solve that for n. What am I going to do first? Yeah. Subtract 5 from both sides. I love it. That gives me 1,495 equals 2n. Divide both sides by 2. Love it. That gives me 747.5. which is a long time, right? What? Yeah, so then divide that by 60 once. So 12.4 hours. Okay? Alright? So 12 hours. Which is why a lot of people that have pools, I don't know if your family has one or not, my family doesn't, so I don't know, but a lot of people that have pools, they call up the fire department and have them come fill it. Because they'll bring the fire truck over and they'll pump a truck and they'll just pump it right in. Off the pump truck. Yeah. Okay? Alright? Love it. Number 3. I'm more sophisticated than my little sister, so I save my money in a bank account that pays me 3% interest on the money in the account at the end of each month. If I take my money out before the end of the month, I don't earn any interest for the month. I started the account with $50, so that means I started, so that's 0 and 50. That's my start. Okay? What is, with a 3% interest, what is, well, first off, is it arithmetic or is it geometric? It's geometric because it's percentage, right? Okay? So with 3% interest, what is my R value? So what am I multiplying by to get the next term? Say it out. 1.03. Yep. 1.03 is my R value. So that means then, and after the first month, how much money would we have? $51.50. Second month. How much in the second month? I thought you had it. Nope, too much. But we're dollars, right? So that means I can only go to 2 decimal places.
66.
How much? Nope, way too big. 53.05. Third month. Anybody? 6.3? I go 6.4, right? Because we round up. 54.64. Fourth month. Oops, I made that way too small. I already know that.
56.27.
0.28 because it's 5 after it, right? Okay. With me on this one so far. Okay. All right. Graph it. Months. And money, right? Dollar bills, y'all. What do we want to go by as our scale? Probably 5s, right? I think that would be the best choice, would be a 5s here. So 5, 10, 20, 25, 30, 35, 40, 45, 50, 60, 70, 80. Okay, so we started out here, then we went to 51, then we went to 53, then we went to 54, then we went to 56. Okay. Next one would be 58. Next one would be 59. It's changing every time though, right? Okay. Not changing by much, but it is slightly changing. Now my question to you is, So the first example that we had, oops, too far. The first example we had here was a discrete function, okay? Because we only had those dots, okay? Then this one we drew it in. This is an example of a continuous function. Yeah, that's about continuous. Because I could connect the dots. Okay? The water was flowing all of the time. Is this example discrete or continuous? This is a discrete one because it said right in the problem that you don't get any interest if you pull out early. Okay? A normal bank is continuous. They'll give you that interest as long as your money was there. Okay? Alright? So don't connect those. Leave those just dots. Okay? So our recursive equation here was f of n is equal to 1.03 times f of n minus 1 with my 0th month being $50. And my explicit equation would be f of n equals 51.50 times 1.03 to the n minus 1 power. Or we could have gone 50 times 1.03 to the n minus 0 power, which is the n. Okay. Does everybody have those three written down with everything that they need? Because now we're going to contrast and compare them on the next one. Or is there another? There's another one yet? Yeah. Yeah, another one to go yet? Boy. Hold on. Yeah. Oh, no, I'm not even going there yet. Okay? We're at number 5. Okay? Compare problems 1 and 3. What similarities do we see? What differences do we notice? At least two of each. Okay? So problem number 1 was Piggy Bank Savannah. Problem number 3 was bank account Savannah's elder sibling.
Should be about would the similarity be paying accounts for money?
So we're talking money. Okay. All right. A similarity would be that we are talking money. Okay. I would concur with that. What else?
They both have a sibling. Let's see.
They're both dealing with months? No, because the first one was in days.
No, I meant they both have siblings.
Oh, well, because they're siblings to each other. Yeah, that's just part of the story. That's not helping me with the sequence, with the actual numbers. Yeah. Okay. What got?
Well, a difference is that this one's American, it's different.
Okay, that would be a difference. Yep. 1 is Aerith. 3 is Geo. Okay. That would definitely be a difference.
They're both increasing.
They're both increasing. Okay. Would that be a similarity then?
Yeah.
Are they one is? 1 and 3?
Or one is discrete and the other is. Oh wait. They're both discrete.
Wouldn't they both be discrete? Did we say that they were both discrete?
Yeah.
Yeah. Okay, so that would be a similarity then, right? Yep. What else are we thinking for a difference? Are you trying to do your homework here right now and we're still doing this one and we haven't even figured this one out yet? Think of any other differences? Yeah.
One is pennies, that is dollars.
Okay. Yeah, that's a good one. Because it's different. It's different units, if you will. Yeah. Yeah. Number one is in pennies. And number three is dollars. Okay, I like that. Now let's compare 1 and 2. Okay, 1 and 2. So number 1 was pennies, right? And number 2 was gallons in the pool. Okay, similarity or a difference. Come on, give me a similarity or a difference between 1 and 2. Somebody else, give me a similarity or a difference. You had your hand up first. Lydia.
One is discrete, 2 is continuous.
Okay, so 1 is discrete, 2 is continuous. Elliot, was that what you did? She steal yours? No. What was yours then?
Mine was similarities is both arithmetic, I think.
Both are what?
Both are arithmetic. Addition.
Both are but yeah. So they're both arithmetic. Yep. Mm-hmm. Yep. Both are arithmetic. Yep. What else we got?
Measured in different units.
Both increasing. Yeah. In number 2, what happens after 747.5 minutes? So what happens?
It ends.
What do you mean it ends?
I don't know.
No. What do you got?
Like you can't go any longer.
So what do you do?
Terminates.
So if it was your pool, I'll go back to you started. If it was your pool, what would you do?
Turn off the water.
Turn off the water, right? Right? So can it get any bigger than 1500?
No.
No. Okay, so there's an upper bound to it, right? There's an upper limit. There's a maximum to it. Okay? So number 2 has a maximum. With Savannah's piggy bank, is there a maximum that she can put in that piggy bank? We're going to assume every once in a while she empties it and go puts it somewhere else. You know what I mean? And we're gonna assume that. Okay. So is there a limit to her piggy bank? No. Okay. So number 2 has an upper limit. Okay. We can't put more than 1,500 gallons of water into the pool. With me? Yeah? All right. Good times. Now, I believe that there is a takeaways page down here at the bottom of page 5, and does it continue on to the top of page 6? Nope, just at the bottom of page 5. So I would like you to write down this stuff on the takeaways page where it says so. So discrete functions are here, continuous functions are there, arithmetic and geometric sequences are there, domain of a function. So this stuff, I want you to write this stuff down as the last part of what we do today. So we'll come back to this here momentarily. I just want to point out then that your homework this evening is in your blue packet now, not your yellow packet, your blue packet from pages 2 to 4, and it will encompass problems 1 through 27. I don't think, if memory serves me right, it's not that there's a lot of problems, yes, but there's not a lot of work to be associated with each problem. Okay?